Radiation detectors, dosimeters, Geiger counters. What should you use? Let's learn more. Radiation detectors, dosimeters, Geiger counters. We get asked all the time, what is the right instrument to use to check radiation coming out of our X-ray machines? Now, the FDA regulates radiation exposure here in the United States, and workers are not, or operators of X-ray machines or cabinet X-ray machines are not required to wear a dosimeter or a radiation detector, because in a cabinet X-ray machine, all the radiation stays inside the cabinet. The walls are fully shielded and all the access points are interlocked. So there's no radiation coming out. They might expose the operator to radiation. And that's why an X-ray machine or a cabinet X-ray system like the ones we sell make a radiation area. So you don't have to put any postings and you don't have to wear any dosimeters. But let's go through the instrumentation, what's available in the market, and we try to map what's out there, and so you have a better idea of what's available and what you use and when to use it. Let's start with dosimeters. Dosimeters are devices like this. They're small. You wear them in your lapel. As you can see, they are individualized. So each person, each operator has to have one of these dosimeters. This is specifically is a TLD badge, thermoluminescent badge, and this is a typical panel that you see on a company. I used to work at Fermi National Accelerator Laboratory. I was the radiation safety officer there, the RSO. We had a panel like this with, in the morning when you go to work, you take one from the board, put in your jacket, in your shirt, and after you're done working, you put it back here. These are rings. If you're working with radioactive sources, for example, you need to monitor radiation in your extremities. Rings are also available. This device, the TLD badges, they accumulate radiation over time, and after a month or 3 months, you send them out. The Landauer is this provider here. Send it back to them. This is from January to March, for example. You send it back to them, they do a reading and send you a report saying what's the dosage for each one of these badges. You gotta be careful. I've had people taking this on flights and going through X-ray machines at the airport, which completely screws up the report. And it's a liability because now you have to explain in a lot of documentation why these measurements were out of the normal range, which is background radiation. Another device that's commonly used in nuclear power plants, mammography system, X-ray labs at hospitals, or dentist offices. This is a very directed way to look at radiation in real time. It's the size of a pen, and it accumulates radiation, and you can actually read how much radiation has been accumulated within the device using this gun-looking device. You put the pen in here on the top, you pull the trigger, it illuminates the end of the pen, and you can, using your eye, you can actually read how much radiation has been accumulated, and after a while you can go ahead and reset it, 0, so you go back to 0 dosage. Again, these devices that I just showed you, the TLD badge and the pen, these are widely used in high radiation environments. So nuclear power plants, medical offices with radiation therapy, nuclear medicine facilities, dentist offices, places where you are going to subject it. The operator is subjected to radiation. So this monitors how much radiation is being given to the operator. And then there's another whole different class of devices. These are radiation detectors, specifically Geiger counters. Those Geiger counters, you can find them on Amazon for $50, $100, widely used. You can make one at home. It's not hard to do. These devices are qualitative devices. What I mean by that is they tell you if radiation here is more or less than there, right? So it's a qualitative measurement. You cannot use these devices as a measurement of dosage because they are not properly calibrated. Let me show you the response curve of one of these devices, right? As you can see, most of these devices are normalized to cesium-137. Cesium-137, the main peak of energy is at 662 keV, which is right here. The X-ray photons that are coming out of an X-ray machine is in the 100, 130, maybe 80 keV, which is right here, right? As you can see, the Geiger counter is normalized, so it gets you 1 click per X-ray photon or gamma photon coming out at cesium-137, which is 662. At 100, 90, 80 keV, you're going to be getting almost 10 clicks per X-ray photon. So these devices, they have a tendency of giving exaggerated readings for lower energy X-rays, and for that reason, you can't really use them for any measurement of dosage pretty much in any energy level. As I said, they're qualitative. People like to use them. And for example, if you live near a power plant and you need how many clicks you're getting per minute or per second, and then all of a sudden you get way more, something happened. And if you're next to a nuclear power plant, something might be coming from there. The proper instrumentation to measure radiation coming out of an X-ray machine are ion chambers or this compensated Geiger counters. This red IG is compensated, and the compensation, what it does is to flatten that response curve so you get one-to-one readings using lower energy X-ray photons. So you get a proper measurement of dosage using a device like this. And we sell them. If you need one of these, just give us a call and we can set you up on one of these. Ion chambers are also very powerful, very accurate measurement of radiation dosage. They are really expensive, and somewhat fragile. Mechanically, they're not as rugged as these red IGs that you can drop on the floor and all that, and they'll keep on kicking. So these are more sensitive instruments, but again, very accurate and widely used. This one, for example, has a mica window for alpha and beta readings that the red eye doesn't really have, but really don't need that for X-ray. If you're just looking for something to read radiation out of X-ray machine, this is the device you have. And also, whatever device you use, make sure it's properly calibrated. You need to see annual calibration tag on the devices, and you need to know that the energy at which they were calibrated. So we calibrate our device to 100 kV, which gives a nice curve at the energies that our X-ray machines work. So I hope this video was useful. If you have any questions, go to our website. There's a Contact Us Now tab. Just go there, send us an email, send us a message. We'll be happy to make a video to address any questions you might have. And as usual, do not forget to subscribe. Thanks for watching.